Evening students, today we are going to see the compiler design, that is compiler design 5th unit runtime environment. Okay. So we runtime environment, runtime means what? Whatever the program we have written that should be run, then only we can get the output. Okay. So that environment is called a runtime environment. Okay. So before code generation, static source code, source set of program be related to the action that must occur at runtime to implement the program. So to implement the program, the code generation at a source code will be related to the action. So that is the runtime. Okay. As execution proceed, same name in the source text denote different data objects in the target machine. So execution proceed, same name in the source text, denote different data objects in the target machines. Okay. So after when the execution starts, that a name in the source text, the name in the source text shows different data objects in the target machines. Okay, it will show the different data in the target machine. Okay. The allocation and reallocation of data objects is managed by the runtime package. Allocation and reallocation of data object is managed by runtime package. Okay, so that is the runtime means what? The code generated at a static source program. Static source program means what we are writing C program or other C++ program or for Java or any code generation, that is called a source program. Source program, what we are returning is the source program. Is to relate, it should be related to the action, but must occur at runtime to implement the programs. It must be, the actions must be implemented at the runtime to implement the program. That is called a runtime environment. Okay. So next, source language issues. Source language issues. That is the what you are writing is the what program we are writing is the source language. That what will be considered is each execution of a function is referred to as an activation of the procedural function. Okay. Each execution of a function is referred to as an activation of the procedure function. Okay. So every time when your program is written, there will be start at a runtime. It will be executed. That action list will be referred to as a procedure function. Okay. If the function is recursive, means several actions will be alive at the same time. Okay. If the function is recursive, means recursive means what? It will be repeated at the repeated the codes until the condition is satisfied. That is called a recursive. For example, if you want to find a factorial means, if you want to find 5 factorial means, it will be executed up to 5 factorial. Okay, that is 5 into 3 into 2 into 1. Okay, so that it will be calculated the values. Okay, so that if the function is recursive means several activations may be alive at the same time. Okay, so several actions will be alive at the same time. Okay, ma. So next, procedure activation and lifetime. Procedure activation and lifetime. So already we have discussed procedure means what the program we are written, that is function it will be activated when activated at runtime. So what is the lifetime of the activation procedure? The lifetime is the running time taken runtime, the execution of the procedure body from the first step to the last step is the lifetime. Okay, until it ends, it is the lifetime of the procedure body. Okay, so the procedure is activated when called. Okay, the procedure when you are at runtime, the procedure is activated when called. Okay, when it is called, the procedure is activated. The lifetime of an activation of a procedure is the sequence of steps between the first and last step in the execution of the procedure body. Okay, so that is the lifetime of an activation of a procedure is a sequence of steps. It is a sequence of steps between the first and last step to the execution of the procedure body. So when it starts the activation and it's when it comes to the last step, the execution, the last step in the execution in the procedure body. That is the lifetime. Okay, so the procedure is recursive. If a new activation can begin before an earlier activation of the same procedure has ended. The procedure is recursive. If a new activation can begin before an earlier activation of the same procedure ended. So if it is a recursive means it will start a new activations. Okay. So we are the earlier activation of the same procedure has ended. Okay. So after they ended the earlier activations, the recursive procedure will be started. So the recursive procedure will be started. Okay. So this is the procedure activation, and the lifetime of the procedure is in the at the runtime. Procedure activation and their lifetime in the of the procedure in the runtime environment. Okay. And then next, activation tree. What is meant by activation tree? We use an activation tree to depict the way the control enters and leave activations in an activation tree. Okay. So what are the actions what are the actions taken in the in runtime? What are the actions taken and leave the actions that will be depicted as a activation tree. That will be depicted as a activation tree. Okay, so the activation tree, whatever the actions taken in the are taken at a runtime will be shown as a activation tree. So each node represent activation of main program. Each node represent activation of main program. Okay, so every node represent the main program, activation of the main program. Okay, so for example, if you're considering a node A and node B, so okay, so node A is the parent of the node for B. So the node A is if we're considering a node, two nodes A and B, so A is the parent of the node for B. So for B, no, A is the parent node. Okay, so if the controls flow from activation A to B, so that is in we consider A is the parent of the node of B when activation comes from A to B. Okay, so the node for A is to left of node for B. So the node for A is to left of node for B. Okay, so the A node is to left of node for B. So left of node will be B. So if the lifetime of occurs before the lifetime of B. Okay, so the lifetime of A occur before the lifetime of B. Okay, so it will be activated when the node A and then activated the node B. Okay, so this is the activation tree of your program. Okay, so every node, if we have different nodes, means it will be parent node will be there, and that the child will be activated. So every starting program, the node A is the parent node. From the parent node, it will be transferred to the activation of the next node. Okay, so and then if we have B have another node, means it will goes to the another node. Okay, likewise it will be goes under the DFS method. Okay, DFS depth first. So, depth first. So next, activation. This is an example for a activation tree. Okay, so we are considering the activation tree. So we are considering the sorting method. Okay, by using a sorting method. So sorting method means what? We are arranging the numbers in an ascending order. We are arranging the numbers in a ascending activation tree for the sorting program, also referred as dynamic program. So when the activation acted, the activation tree will be the activation tree can be implemented according to the activation enters. Okay, so A is the node parent, S is the store. This is the start node. Okay, so start node, it will access the values. Okay, so that is Q1,9. So here we are considering the arranging the numbers as using a Pixar. Okay, so Q of 1,9, Q of 1,3, Q of so every number is entered. Okay, so every number is entered. So according to the it will go to the left section Q of 5,9. So it will be partition the values and arrange pivot value. According to the pivot value, it compare the values and it will compare the values and rearrange the number. So each activation is showed as a node. So node as a node. So control stack. Control stack means what? The flow of control of a program. Okay, it controls the flow of a program. Corresponds to DFT, that is depth first traversal of the activation tree. Okay, so how it flows through the activations. Okay, so control stack is useful to keep track of the live procedure activations. It keep track of the live procedure activation. So when the procedure activated, it will be followed by the control stack. It keep track of the live procedure. Okay. So the idea is to push the node when activation begins and pop when it ends. Okay. So the control stack will use it to push the node. Okay. So already we discussed node means it is an activation tree. Procedure is noted as a node, and then it will when activation begins. So it will start from the one node to another node. So and end with another node. Okay. So when the idea is to the control stack push the node when activation begins. That is push means it enters the node. Okay. So then activation starts and then pop when it ends. So when the activation ends, it will be popped up. It will be come out of the activation. Okay, so the actions we already discussed that it will keep track of the activation tree. Okay, so this will be controlled by the control stack. So it will control all the flow of the programs functions. Okay, so every function when every function is activated, it will keep the track of the procedure activations and ends. Okay, so this is the control stack. Okay. Next, addition of elements of array recursively. So already we have discussed recursively means it according to condition, it will be recursive. It will be called again, and it will store the values. So using that functions, we are using public static integer add integer index. Okay, so we are declaring the variables, declaring as a public. If index equal to 0 means it will be come out of the loop, sum equal to array of index. Okay, so if index is equal to 0 means sum equal to array of index, it will return as 0 and it comes out of the loop. Else it will be added. If it is not 0 means it will be added. That is sum equal to sum plus add of array of index. Okay, so it will be added. So it will if we are getting a 5, if we are getting array of 5. Array of 5 means it will store the values starting from a of 0 to a of 4. Okay, it will store the values. So it will be added one by one. So say index of 0, index of 1, index of 2, index of 3, and index of 4. So the sum will be calculated and it will return the sum. Okay, so it will be called again and again. Okay, sum plus add array of index until the condition is equal to becomes 0. Okay, becomes 0, it will return the sum. So this is the addition of elements of array recursively. So in this, it will be called the functions. Okay, so the functions activated. This is the simple functions activated, and then if index is equal to 0, sum equal to array of index, else sum equal to sum plus add of array of index. Okay, and then return sum. So it will leaves the after returning the sum, it will it will stop the activations. So this is an example for a function to activate it and leave the function. Okay, so that is the example for array of elements, array of addition of elements of array recursively. Next, control stack. So already we have discussed activation tree will say implementation of the activation of the functions. So functions that is procedures. Okay, so it will control stack control. It will keep track of the activation tree. It keep track of the activation tree. Okay, so this is the activations we are going to start. So activations, this is the activation tree, control stack, and activation. What are the activations activated when you using a sorting program? Okay, so first it will start from begin. So first begin start. Okay, so begin start is the statement, and it will enter into the read array. So it will enter into read array means it will read the values. So what are the values we are entering? That will be read. So okay, after reading the value, it will use the read array. So if the function is that reading function is closed. Okay, leave the function, leave read array. Okay, to leave the function. Enter quick sort. Okay, so entering into the quick sort. Okay, so that is it is 1, 9. So up to 1, 9 we are entering the values, entering the enter partition. So according to the values it will be partition. So okay, after partition it will be leave the partition. Okay, so again it will enter into the quick sort. So first it will enter quick sort, enter partition, and leave partition, and then enter quick sort. So here again it will be quick sorted and enter partition. So every quick sorted is sorted. It will be with the pivot value is partition is repeated, and again it will be sorted. Okay, so enter quick sort and then leave quick sort, and then enter quick sort. It will leave the, so it will be continue until the controls go back. Okay, so until the program activation ends. Okay, so it will the partition is occur, partition after partition it will enter into quick sort. Okay, and then it will leave the partition. Okay, so this is the this is the example for a sorting method for a control stack. Okay, next, binding of names. So already we have discussed name. Name means for name is to store the values. Okay, so that is if we are declare the variables in the a program. Okay, we declare the variables in a program. So the variable will store the values at a runtime in a different way. Okay, so that is if your name is declared once in a program, it can hold different values at runtime. Different values at runtime. Okay, the term environment refers to a function that maps name to a storage location. The term environment refers to a function that maps name to a storage location. So the term environment refers to a function that maps name to a storage location. So, okay, at runtime it will store it will store the values in the locations. Okay, that is the memory location. Okay, the term state is referred to a function that maps a storage location to the value held there. Okay, so it will be changed. It will, the values will be moved from environment to another state. Okay, it will move from one state to another state. That is called a map. Then that when the location to the value held there. So, okay, so this is the binding of names. The name will be vary at a runtime. So this is the mapping names to values. Okay, that is name, environment. So it will be stored. Okay, so whatever the values we are given, that will be stored in the environment. Okay, so after that at runtime, it will change the state to value. So the storage will be store the values. That is for that example where I equal to 0, it's I equal to I plus 1. So first starting value for I value is 0. Okay, and then it will be incremented. So I equal to I plus 1 means I equal to 1. Okay, so it will be changed with it. If again and again it will be run means I equal to 1 plus 1, 2. So the values will be changed. So that is the example for name, environment, storage, state, and then value. Okay, so this is the example. So the mapping names to values at compile time at runtime. So okay, so whatever the names we are declaring at a program, that will be stored in the at a compile time, stored in the stored at storage, stored in the at a compile time. So when it runs at runtime, it will be stored the values. It will store not only single value, it will store different values. Okay, so that is the same example where we are declaring the I variable. I starting value I value is 0. Starting value I is equal to 0. I equal to I plus 1. Okay, so the value will be changed during the runtime. Okay, the environment and states are different. Okay, so environment we are we are entering the name to store, and then states are we at the runtime it will changes. Okay, so the assignment changes the state but not the environment. So it will be changes the state at runtime but not at the environment. Okay. So this next static and dynamic notion of binding. Okay, static notion, dynamic notions. Okay, static notion means what? Definition of whatever program you are written, that is the static notion. Dynamic notion means whenever the program run at activation starts, it is called a dynamic notions. What are the actions done at a dynamic? That is called a dynamic notions. Okay, so static notion, definition of a procedure, declaration of a name, and then scope of declaration. Okay. Definition of a procedure. We are defining the what are the procedure we are used in the program, and then what are the variables we are used in the program, and then scope of declaration. What are the values to be defined? What are the procedure? What are the actions to be action to be taken should be defined in the scope of declaration. Okay, so that is next. It will be activated during the dynamic function. That is activation of procedure. So the procedure start activated. Okay, whatever we defined in the static, that will be activated in the dynamic notion. Okay, so activation of procedure. Next, binding of the name. So the name will be stored in the memory, storage device. Okay, so binding of the name. Okay, next, lifetime of binding. So when the procedure activated, it will be started and it will ends until. Okay, and that is called a lifetime of binding. So, okay, so when the procedure starts and ends, that is the lifetime of binding. Okay, so this is the static and dynamic notion of binding. Next, storage organization. Okay, so that is runtime storage may be subdivided as runtime storage may be subdivided as generated target code. Okay, so then the first we are generating a target. So what output we are going to get. It is for that we are writing. We have written a target code, and then what are the data we are used in the program that should be declared. What are the data to be declared, and then next it will keep track of procedure activations. So the control stack keep track of procedure activations, and then next size of target code is fixed a compile time. So it will start and ends, no, that is the lifetime of the target code. So it will be fixed when it will fixed at a compile time. So compile time. Okay, so next, similarly, the size of data object may be similarly size of data object may be known. Okay, so data object may be known means how the data according to the variable names it will be stored with the store the values. Okay, so that is the runtime storage may be, that is generated target code, data objects, and keep track of procedure activations, that is controls the activations, and size of target code, and then size of data objects may be known. So this is the storage organization. How the values are stored in the stored in the memory. Okay, so this is the storage organization. So next, typical subdivision of runtime memory. So at runtime, what are the actions they will be taken that will be stored in the memory. Okay, so that is separate area of runtime memory called heap holds all other runtime information. It will store all the other in runtime runtime, what are the actions taken, it will be stored in the memory. So that memory is called heap. Okay, so it will, what are the informations it will store means code. So whatever code, static data, stack, and then heap. Okay, so code means whatever the program we have written, that is called a code. So next is static data, that is whatever the variables we are declared is static data. And then stack. Stack we will keep the track of the activations. It will keep the track of the activations, or it will keep the values of the values to be stored and to actually during activation, and leaves when it is when it leaves, it will be popped. That the values will be removed. Okay, so this will be stored in the heap memory. The memory called heap. So during the runtime, a separate memory will be activated, and when the at a runtime to hold the runtime informations. Okay, whatever the actions that occur at the runtime, it will be stored in the um, heap. Okay, so this is a separate memory, and during separate memory used to store the data. Okay, next stack allocation. Already we discussed stack means what. Stack it will be push the value, then the activation start, it will be push the value, and then it will pop when the activation ends. Okay, stack allocation. Okay, so that's activation record, that is subroutine frames. So that is a function frame on the runtime. Stack holds the state of a subroutine. Okay, so what are the actions to be taken, that will be hold in the stack, that will be hold in the stack, and it will ends, it will leave the, if it ends, when it ends, it will leave the stack. Okay, so the calling sequence or code statement to create a activation record. The code calling sequence or code statement to create activation record on the stack and enter data in them. Okay, the calling sequence or code statement to create activation record on the stack and enter data in them. Okay, when we call the sequence code statement created. Okay, when we call the sequence means when it is called, in a code statement create activation and record on the stack, and if your data is using means it will enter the data in them. Okay, so what are the calling sequence used in the stack means callers calling sequence, callers calling sequence, and then callers return sequence, and callers return sequence. So first one is callers calling sequence means what? It will call and to enter the actual argument. So what are the argument we are used in the program to be entered? Okay, so that is callers calling sequence enters actual argument. So it will get the actual argument. What are the arguments we are used in the program, that will be get. Okay, so it will calling sequence, callers calling sequence. Next calling sequence initialize local data. So what are the variables we are declared, that will be initialize the value. Okay, so after that, after runtime, the values will be changed. Okay, at initial condition, the data will be stored and so it will be called. Okay, so that is callers calling sequence initialize local. First it will be initialize the local data. Okay, so next callers return sequence, so it will be return the value. So that is it enters the return value. So whatever the program we have written, it will get the output. No, so we'll get the required values, we'll get the required output. Okay, so that sequence will be returned, enters the return value. Okay, so callers return sequence removes activation records. After that, after the activation ends, it will return sequence removes activation record. Okay, so this is the calling sequence of when it calls and when it leaves. Okay, callers return sequence removes activation record. So it remove after entering the values, will remove the activation record. Okay, so this is the calling sequence for running the code statement. Okay, so code statement, that thing, but yeah, the program. Okay, so program, whatever the program for written. Okay, so in the program we called a function. So particular function is called means it will be created. It will be create activation. Okay, and enter data. The what are the values we are using that function means it will enter the data. Okay, so that sequence is used by the calling sequence. Okay, so the first action is what, entering the actual. In that function we are enter actual argument. So what are the arguments we are using in the program, so it will be entered. Okay, so every that entered actual arguments will be used in different functions. Okay, different functions in different name. Okay, so that for in first sequence it enter the actual argument. Okay, so next calling sequence initialize the local data. It will be initialize the local data. Okay, so it calls return sequence, enter return value. It will render the return, whatever the output we are getting, that will be returned. Okay, so after that, after getting the output, we are if it removes the activation record, it stops the activations, and then it will be, and if there is any other activation record, it will that record will be activated. So that function will be activated. We can call it as the program will be function, subroutine, procedure. According to the program, we can define the activation record. Okay. So in this calling sequence, the code statement created, initialize local data, enters return value, and it removes activation record. Okay. So this is the stat allocation at the runtime. Okay, it will stack. That's already we have discussed. Stack means it will holds the state of a subroutine. Subroutine nothing but a, when subroutine is nothing but a sub function or a procedure. Okay, so when the procedure starts the activations. So in the example we have seen, no, quick start. Okay, so first action mode, activation mode, it reads the value. If that is read the value from the array, it reads the value. Okay, so when it starts reading the value, where it will be stored, it will be stored in the stack. So it leave the read array. Okay, so now quick start, first activation is what, it get the array value and it will stop the value. Okay, stop getting the value. So first it will get the value, and it will stop getting the value. Okay, so this one, first one. Okay, and then again it will start quick start. So after quick start starts, it will partition the value. Again it will be start the quick start. Again it will partition the value. Okay, so likewise the sequence of activations will be activated. That activation record will be stored in the stack. Okay, so it is the runtime stack. It is also called as runtime stack. So at the runtime, what are the actions taken will be stored in the stack. Okay, so if you are using values, that the values will be stored in the stack. So if you are declaring the variables, that will be stored in the stack. So after the activation record stop, activation ends means it removes all the values. That is, it will pop all the values from the stack. Okay, so it remove all the values from the stack. Okay, so the stack will be empty. So another function is called means it will show stack. The stack will hold that activation record, that activation procedure. Okay, so once the procedure is over, procedure is over, it will be pop the stack. Okay, so the main action of the stack is to push the value, that is entering the value, and then it entering the value when the activation starts, and ends, that it pops the value when it ends. Okay, when the activation stops, it will pop the value, it will remove the value. Okay, so same procedure is used in the calling sequence. Okay, so firstly entering the actual argument, entering the initializing local data, and it enters the return value, and it removes the activation record. So this is the procedure followed in the stack when the activation record starts. Okay, so this is the stack allocation at runtime. Okay, so what are the topics we have discussed? Is stack allocation, runtime memory. So what are the what memory is used run at runtime? So separate memory is used at runtime, and then storage organizations. So how the storage is organized, and then next static and dynamic notion of binding, and then mapping names to values. So mapping names to values, and then mapping names to at runtime and at compile time. So that is the, it will be, the name will be stored in the environment, and the stored value will be changed the state when the we change the state at runtime. Okay, so next binding of names. So declaring the name means it will hold different values in the runtime, and then it will control stack. So it will control all the values, control all the controls. It will keep track of the activation tree. When the activation tree, it keep all the controls in the control. It control all the values. Next, it is addition of elements of array recursively. Okay, so next control stack. It will keep the control of the flow of the program. So this is an example for a activation quick sort. It is an activation tree. So what are the actions actions taken at runtime? It is shown as a activation tree. So okay. So next, procedure activation and lifetime. So when the procedure activated, and what are the lifetime, when lifetime starts and it ends. Okay, so when the procedure activated starts, and if it ends means that is the lifetime of the language. And then source language issues. It is a for execution of a function is referred to as a activation of the procedure function. Okay, so this is, it is, if it is recursive means the activations may be alive at the same time. Okay, so this is the runtime environment. Okay, so what are the actions done in the during the runtime environment? So up to this we have seen the compiler design, runtime environment. We'll see we'll finish it off. Thank you.